we gonna get our test back before break?
Oh, I didn't give them back? Probably not today. Maybe tomorrow, though. Okay, so when we have an imaginary number, well, let's go before we have an imaginary number. If I was solving a problem and we got to this point, x squared equals -1. Up until today, we would stop, right? And we'd be like, no real number solution. The key word in there was real number solution. There is no real number that would solve this because any real number times itself is always what sign? Positive or negative? Positive. A negative times a negative is a positive times a positive is a positive. No real number times itself will give us a negative number. So that's when imaginary numbers come in. So we now say that I is equal to the root of -1.
Do we have to draw the eye like that? Or
No, that's just how I do it.
I'm just curious.
You have a very small pencil.
It's actually pretty big.
I have pencils on my desk if you want one.
That's fine.
New year, new pencil?
It works.
Okay. So we have I is equal to the root. Yes, Kai?
I have them in my last room.
Yeah, they're on my desk in the cup.
It's so funny for nothing.
Okay, so we have I is equal to the root of -1. Well, if I is equal to the root of -1, what do you think I squared is? Root -1 times a root of -1, which is? No. -1. Hey, in the next lessons to come after this one, we'll continue. We'll go all the way to I to the 4th, and then we'll see a pattern from there. But for the purpose of today's lesson, we're stopping at I squared. So now let's just simplify. We are never, ever, ever allowed to leave a negative underneath a radical. So if I have the root of -16, I'm going to go about this the longer way first just to show you. I could make this the root of -1 times 16. And if it's multiplication under a radical, am I allowed to split up that radical? Yes. If it's addition or subtraction under the radical, am I allowed to split it up? No. But because it's multiplication, this is saying this is the root of -1 times the root of 16. And what did we just say the root of -1 was represented by? I. And what's the square root of 16? 4. So we end up getting 4i. Hey, obviously we do not need to go through that long process every single time. We can just simplify. So if I have the square root of -7, you are never, I'm going to say it again, you are never ever allowed to leave that negative underneath the radical. You pull out an I. Because I cannot simplify the root of 7, it just becomes I root 7. Give this one a try. See what you think ends up happening here. So the first thing I did was pull out an I, because I don't want the negative there. But then when I pulled out the I noticed root 12, can't that be simplified? So we have to simplify it. Any radical that can be simplified must be simplified. So in my head, I'm thinking 4 and 3. 4 becomes 2 and 2. There's my pair. So we are 2i root 3. How many people got that? Good. All right, now when we're simplifying radicals, remember, we always account for just the positive version. So when I have the root of 16, I only account for the positive 4. But when we're solving for a variable, am I allowed to only account for the positive? No, we have to account for positive and negative. So when you're simplifying, it's just positive. When you're solving, you need to account for positive and negative. So in this next section, we're solving for x. So if I have x squared minus 5 equals 0, remember before the break what we had to do was isolate our x squared, get it all by itself. So this is going to be x squared equals 5. To undo a square, we take the square root. The minute I take a square root, what must I put in front? Plus or minus. So x is equal to plus or minus root 5. So here I have 2x squared plus 16 is equal to 0. Once again, we want to solve for x, so I need to isolate the x squared. So I'm going to subtract that 16 first. Then I'll divide by 2 on both sides. And I will get x squared equals negative 8. Before today, we would stop here, right? And we'd say no real number solution, doesn't work out. But now we know there's a world of imaginary numbers, so we can continue. We're going to root both sides. The minute I square root both sides, I need a plus or minus. And because of that negative underneath, I'm immediately going to pull out a plus or minus I root 8. I'm not done. Why am I not done? Yep, root 8 can be simplified. So we are x equals plus or minus 2I root 2. All right. So we're going to say a plus bi is defined as complex when a is a real number, b is a real number, and obviously I is our imaginary. Every number can be written as a complex number. An example of that, let's say I had 5 or negative 5. Let's say I had negative 5. And I wanted to write this as a complex number. So in order for it to be a complex number, we need a to be a real number. So we want a plus bi. That's the complex form, a plus bi. A needs to be a real number. B needs to be a real number. I is imaginary. So I have my a. So this is going to be negative 5 plus. Now I need some number times I. But in reality, is there an I in negative 5? No. So what number needs to multiply with the I to basically eliminate it? What number can we multiply I by that would essentially eliminate that I? Make it go away.
0?
0. Right? 0 times anything, isn't that 0? So that's how we can change a real number into complex form. Negative 5 plus 0i. Okay, let's simplify. So if I have 3 plus the root of negative 4. Never leave our negative underneath the radical. So we're going to have 3 plus 2i. in this 3 plus 2i, this is absolutely in complex form, a plus bi. Can somebody identify which number represents our a? Philip? And our b?
2.
2, perfect. Okay, let's say I have -5 root -8. I'm going to simplify. When I simplify, I'm going to get -10i root 2. Now, if I want this in complex form, I need a plus bi. That's our complex form. Do we agree the -10i root 2, that sort of corresponds to this part of our complex form, our bi? So I'm going to write it a little bit differently. This is -10 root 2i. And if there's nothing written for a, what do you think that is? 0. So my a is 0, and my b is -10 root 2. The b does not have the I in it. The I is separate. So my a is 0 here, my b is -10 root 2. Okay, you guys do this next one on your own. I want you to simplify and then identify what's your a, what's your b. So when you simplified this, all you could do was pull out the I. So we get 2 minus I root 10. Can somebody tell me, what did you identify as A? 2, perfect. What did we identify as B? Negative root 10. Very, very good. That negative belongs with the root 10. Perfect. All right, let's keep going. So let's talk about adding and subtracting. So if I have 8 minus 9i plus 6 minus 4i. We treat I like a variable, right? A variable represents a number, right? The same variables represent the same number. Well, I represents the root of -1. So we treat it like we would treat an x or a y. It's representing the same number. So that's why we treat it like a variable. So we're going to combine our real numbers, 8 plus 16, get us 14, and then we will combine our imaginary numbers. -9i minus 4i is a -13i. So now let's say I have 8 minus 9i minus the quantity of 6 minus 4i. I have to distribute in that negative. So when I distribute in that negative, I get 8 minus 9i minus 6 plus 4i. I'm going to combine my like terms, and I will get 2 minus 5i. All right, so let's say I now have negative 9 plus the root of negative 2 plus 6 minus the root of negative 18. I cannot do anything with those negatives under the radicals, so I have to fix those. That's always my first thing. I never deal with a negative under a radical. So we're going to say 9 plus I root 2. Now for the second radical, the root negative 18, I can pull the I out, but can I also simplify the root of 18? So I'm going to do that simultaneously. So we're going to get minus 3I root 2. Then all we do at this point is combine our like terms. Negative 9 plus 6 is a negative 3. And now this is a 1I root 2, and we have that paired with a negative 3I root 2, which is going to give us a negative 2I root 2. Okay, you guys do this next one. Yes.
What do you mean by like root negative 20 plus minus 4?
Oh,
Isn't
sorry.
that minus 4?
Yeah, that's just a minus 4. Same thing. Okay, so what should you have done here? First and foremost, we fixed the negatives under the radical. So we have negative 10 plus 6 root negative 20. I'm going to pull out that I, but when you pull out that I, you should realize you can still simplify the 20. The 20 is 4 and 5, which is then 2 and 2. So we're going to pull out a 2. So this makes it 12I root 5. And then in the second one, all we have to do is pull out an I. We combine our like terms, and we get a negative 14 plus 8I root 5. How many people got that? Good. All right, next part, absolute value. So let's talk about absolute value of real numbers. When we find the absolute value of a real number, for example, if I take the absolute value of 4, it's 4. If I take the absolute value of negative 4, it's still 4. Why? What does the absolute value represent, Philip?
It's the distance of that number from 0.
Yeah, it's the distance that number is from 0. So the absolute value of 4 is telling us, well, how far is 4 from 0 on the number line? And when we take the absolute value of negative 4, again, we're asking how far is negative 4 from 0 on the number line? They're both 4 units. All right, the absolute value of the complex number is a similar idea. How far is it from 0? But now I'm going to do this. I will tell you the shortcut, but I'm going to go about it the longer way first. So if I'm finding the absolute value of 2 plus 6i, we want to know how far is that from 0. Now, when we go to graph this, it's not going to be real numbers. Well, it's not going to be XY real numbers. Our horizontal axis will be real numbers, but our vertical axis will be imaginary. But 0, 0 is still where our real meets our imaginary. So that's still the origin. So when we say 2 plus 6i, it's saying let's go 2 in the real and let's go 6 in the imaginary. And we want to know how far is that 2, 6 So 2 is our real, 6 is our imaginary. How far is that from 0, 0, real, imaginary?
Isn't this just like slope, just the rise over run?
It's not actually rise over run because we want the distance, but you're thinking the right thing. We're not going to use the slope, but we are going to use the distance formula. Remember in geometry, we can always find the distance between any 2 points. So the distance formula, the distance between any 2 points was x2 minus x1's quantity squared plus y2 minus y1 quantity squared. But this time, we're not talking about xy coordinates. What are we talking about? Real and imaginary. So instead of x2 minus x1, we're going to do real 2 minus real 1. So what is that? 2 minus 0 squared. And instead of y2 minus y1, we're going to do imaginary 2 minus imaginary 1, which is going to be 6 minus 0 squared. So because from both real and imaginary coordinates, we're subtracting 0 from them, isn't this just going to be 2 squared plus 6 squared? So the distance between these two will be the root of 4 plus 36, which is the root of 40, which simplifies down to 2 root 10. This was the long way, using the distance formula. We don't want to do that, right? We don't want to do that every time. So what is the shortcut? Well, the shortcut, the absolute value of any complex number, a plus bi, will end up being the square root of a squared plus b squared. And doesn't that make perfect sense? Because when we're using the distance formula, what are we always subtracting from the original numbers? Aren't we always subtracting 0 because we're finding the distance from 0? So if we had the absolute value of 2 plus 6i, it ended up being the root of 2 squared plus 6 squared. So we can use now the shortcut every time. We do not need to go into the distance formula. You guys try this one. I want you to find the absolute value of negative 3 minus 4i. right, can somebody tell me, what did you get? Philip? I got 5 too. Who needs to see me do it? Nobody? We're good? Okay, let's keep going. All right, so we did sum and difference. Now let's go on to multiplying. So let's remember, I is the root of -1. What is I squared? -1, yes, it's -1. So when I have 6i times 4i, we are going to get 24i squared. But what's I squared? -1. So this is really 24 times a -1, which is -24. If I have negative root of -6 times 5 times the root of -3, this is a big, big deal here. Big, big deal. You must, or we must, rectify the negative under the radical before we multiply. That's huge. If you do not take care of the negative under the radical and you just multiply first, you're going to get the wrong answer. You're going to make that negative, those two negatives, into a positive, which then takes away our I, which is a big deal. All right, so we are going to fix the negative first. So we are I root 6 times 5i root 3. So when we multiply, we now get a 5i squared. Oops, I put a 3 here instead of a 6. Root 18. What do we know I squared is? -1. So this is -5 root 18. Why is this not my final answer? Philip?
You can simplify the root of 18.
Good, because we can simplify root 18. When we simplify root 18, we're going to get -15 root 2. Oh, wait, did I lose my negative in the beginning?
Yes.
Okay, so this is a negative, which makes this positive, positive. Thanks. I put the negative in the wrong spot. It was this one was a negative, right? There we go. Better. Let's keep going. Why wait?
How did we lose a negative again?
I just didn't write it. I didn't lose it. I forgot to write it.
How is it positive? I thought it was...
Did you get this? -5i squared?
Yeah, I got -5i squared.
Okay, what's I squared?
Oh.
Kai, you good? All right, let's keep going. All right, let's say I have 2i root 5 times the quantity of 3 root 10 minus 4 root -15. what must I do before anything else? Fix the negative under the radical. So we are 2i root 5 and then 3 root 10 minus 4i root 15. Now can I distribute? Absolutely. So we're going to have 6i root 50 minus 8i squared root 75. All right, 6i root 50, I can simplify that 50 into 25 and 2, pull out a 5. So we are 30i root 2. Now I have negative I squared. What's a negative negative 8i squared? What's a negative 8i squared? Positive 8. So now I'm positive 8 root 75. But I'm not done because I can simplify the root 75. So now we are 30i root 2 plus 25 and 3, pull out a 5, 40 root 3. All right, you guys multiply this out, FOIL it out. Maybe. All right, Kai, what'd you say it was? Kai said it was a squared minus b squared because he treated this like a what? Like a normal what? No, it's not an equation. What did he treat this like? Binomial what? Difference of squares, dots, right? He treated this like a dot, but be careful. That would be an a plus b times an a minus b. How does this differ from this? How does a plus bi times a minus bi differ from a plus b times? The i's change things. Why? What's I times I? I squared, which would make this
A squared plus B squared.
a squared plus b squared.
I did not trick you. I just realized it eliminated. I just realized it eliminated.
Okay, so moral of the story. A plus b times a minus b is a squared minus b squared. Traditional dots, right? But what about a plus bi times a minus bi? A squared plus b squared. Keep that in your head.
So now I'll remember this forever.
Oh, I'm glad. I'm glad you'll remember forever. All right. Let's talk about quotients. Guys, what does I represent? The square root of -1. Are you ever allowed to leave a radical in the denominator? No. If you're not allowed to leave a radical in the denominator, are you allowed to leave I in the denominator? No. How do you think we're going to rectify this? Say it, James.
I said multiply by I.
Yes, we are going to multiply by I. So we multiply numerator and denominator by I. So we get 2i over I squared. But what is I squared? -1, which is just -2i. All right, you guys do this one. All right, who has an answer for me? Phillips are holding up the class today. Somebody else. Kai, what'd you get?
5i/6.
I got the same. Does anybody need to see me do it? We're good? Okay, so now let's step it up a little bit. Let's talk about conjugates. So let's say I have 3 plus I over 2 minus 3i. Do we all agree the problem is I? Can I just multiply by I? Why not? Why can't I just multiply by I? Philip?
Because you multiply by I in the denominator, you're still going to get 2i plus 3.
Yeah, because if I multiply by I in the denominator, you'd have to distribute in that I, so then we just then get a 2i plus 3 and just replacing one I with another I. So that doesn't work. I need to get rid of the I completely. So what can I multiply a binomial by to get rid of the I's? Danny?
2 plus 3i.
You got it. We're going to multiply by 2 plus 3i. Numerator and denominator. So now remember, this is not a minus b times a plus b. This is a minus bi times a plus bi, which is going to give us
4 plus
a minus bi times a plus bi, we said was a squared plus b squared. So we are going to get 2 squared plus 3 squared in our denominator. In the numerator, we have to FOIL this out. 3 times 2 is 6. 3 times 3i is 9i. I times 2 is 2i. I times 3i is 3i squared. Let's simplify this. We are now 6 plus 11i minus 3 over 4 plus 9. Let's keep going. We are 3 plus 11i over 13. No more simplifying can be done, so we stop there. All right, you guys try this one. right, who has an answer for me? Michael? Close. We got one sign error. Max? Minus 13i. All right, let's do it. 16. Okay, so what I did was I multiplied by the conjugate. And when you multiply by the conjugate, you're going to get a squared, which is 25, plus b squared, which is 9. And in the numerator, we get 2 times 5 is 10. 2 times negative 3i is a negative 6i. Negative 4 times I is a negative 20i. Negative 4i times a negative 3i is a positive 12i squared. Keep going. Let's simplify more. We get 10 minus 26i minus 12 all over 34. But then we have the 10 and the negative 12, which is a negative 2 minus 26i over 34. If you stopped here, you didn't simplify completely because we can pull out a 2. When you pull out a 2, you're going to get 1 minus 13i over 34, and then we simplify that. Oh, sorry, that's a negative 1 over 17. There we go. All right, 2 more things I want to show you, 2 more problems I want to show you. Can I eliminate the denominator? Can I eliminate it completely? How many people say yes? How many people say no? Thanks, Tori, for voting. How many people say yes? How many people say no? No, we cannot. Why? Tori, why can't we eliminate the denominator? It's not an equation. We could only eliminate if it's an equation. This is not an equation. We must create a common denominator. Before we create a common denominator, guess what I'm going to tell you to do? Rationalize. Rationalize the denominator first. So for the first fraction, we multiply by I, top and bottom, and we get 2i over negative 1, which is essentially just negative 2i. How do I rationalize the second fraction? Michael? Multiply by its conjugate, 2 plus I. So in the second fraction, we're going to get an a squared, which is 4, plus b squared, which is 1. And in my numerator, I'm going to distribute that 4. So this is 8 plus 4i. Hey, do we all agree now our common denominator has to be 5? So now I'm going to create a common denominator of 5. So that's a negative 10i over 5 plus 8 plus 4i over 5. Now that we have the same denominator, I can add the numerators. So we are 8 minus, doesn't want to write, 6i over 5. Is there anything left to simplify? No. So this is our answer. Yes, Philip?
On the test, will we always have to write the a plus bi form?
Meaning if you wrote negative 6i plus 8?
Yeah.
That's fine. Okay. Yeah. Okay. Last problem I want to do with you. Don't go ahead of me, because we are not allowed to change it into this. Wrong. That gets us the wrong answer. So it's mathematically not correct. Right? Before we divide, before we do anything, same with multiplying. What did I say? Before you multiply, what do you have to do? Take care of the negative under the radical. Same idea with dividing. You cannot do any operation until we take care of the negative underneath the radical. So once I take care of the negative underneath the radical, I'm going to have root of 12 over I root 3. At this point, can I simplify the root 12 and cancel out the root 3's then? Do you guys see what I'm saying? I could make root 12 to root 3, and then the root 3's will cancel. But let's say we couldn't do that, all right? Or let's say you didn't realize you can do that. What would you do? Well, now we have to rationalize. But now in the denominator, my issue is not only the I, my issue is the I and the root 3. So what am I going to multiply by? I root 3. So in the denominator, I'm going to get a 3i squared. And in my numerator, I'm going to get an I root 36. But guys, what's I squared? -1. So that's a -3 in our denominator. And isn't the square root of 36 6? So now I have 6i divided by -3, which is going to give us -2i. Back to the way we weren't allowed to do it. If I simplified the root of -4, what's the root of -4? 2i. Is 2i and -2i, are they the same? No, this yields you the wrong answer. You have to take care of the negative under the radical first. All right, we are done for today. Homework is already posted.